Okay guys, so we finished class yesterday right here, rule number 4, the product rule. So let's just pick up exactly where we left off. So the product rule says that the product of two differentiable functions, u and v, is differentiable. And then when we take that derivative, so the derivative of the product of u and v, that is equal to, I'm going to have to zoom in here to make more space. That is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function, okay? You'll also see it written as u v prime plus v u prime, okay? So just as a quick little example, if you can squeeze it in, if we look at the function, if we want to take the derivative of the function x times x plus 1, okay? When I do this, then I could say that that x function is my u, and my other function, x plus 1, is my v function. So let's look at the derivative of both. I know then that the derivative of u with respect to x by my power rule is 1, and I know that the derivative of v with respect to x is also 1, also from the power rule. So when I put these things together in this formula right up here, it'll look like this. We can say that this is equal to my original u function, right? U, so I need my u function, which is x, times the derivative of my v function, and I know the derivative of my v function is 1, so times 1, plus my v function times the derivative, plus my v function, which is x plus 1, times the derivative of my u function, right? du dx is the derivative of my u function, which is 1, okay? If I go ahead and simplify this, I would end up with x plus 1, which is equal to 2x plus 1, okay? So that is the derivative of your function, okay? Now I know in this case you could have also multiplied that out, right? You could have distributed the x and you would have ended up with x squared. What's the derivative of x squared? 2x. What's the derivative of x? 1, okay? You could have solved it that way too, but it's not, your functions aren't always easily distributed like it is here. I just did this case because it was easy to find these derivatives, okay? We're going to go ahead and prove this rule if we have time in class tomorrow. You can also prove it graphically, so I'll show you both those things next time I see you guys. The next rule we're going to look at is when we look at the product of two functions. So we call, the quotient of two functions. So quotient, again, like meaning divide. So at any point where you have your function y equals u divided by v, assuming v does not equal 0, right? Because you can never divide by 0, and the two functions are differentiable, then we can say, well, I did not leave you guys a lot of space to write this function down. I apologize. Then we can say that d dx with respect to u divided by v is v times the derivative of u, so du dx, minus your u function times the derivative of the v function, dv dx, with respect to x, all over v squared, okay? This formula comes directly from the fact that if you're dealing with a function u over v, that's the same thing as u times v to the negative first power. Remember, when you have a negative exponent, you take the reciprocal of that function. If you were to multiply this out using the quotient rule we talked about up here and simplified it, you'd end up with the same formula. Okay, so this is a formula like I, for example, don't really like to use because I can always fall back on my product rule and then I only need to remember one rule. But it is simpler to just remember both things, okay? So keep that in mind. There's an example of this quotient rule on the next slide. Okay, so example 3 says find the derivative with respect to x of my function x squared divided by x plus 3. So just like we did with our quotient rule, whoa, I don't know where things are happening. Just like we do with the product rule, we're going to identify our u function and our v function. Okay, so we're going to let u, which is always our numerator, is going to equal x squared. And then v, which is always our denominator, is going to equal x plus 3. So when I differentiate both, when I find du over dx, I'm going to use my power rule. Now that I proved it, use it, okay? So that's going to equal to 2x, right? If I take my exponent to the front and then subtract 1 from it, I end up with 2x. And then my derivative of v with respect to x is equal to 1, again, by my power rule. So just as a reminder, so we can keep it on this page to kind of keep it handy for us, we say that the derivative of the function u divided by v with respect to x is equal to v times the derivative of u minus u times the derivative of v all over v squared. Okay, so we're going to go ahead and plug that into our formula. Plug this information right here into this formula right there. Okay, so just like before, we're just going to go step by step. So then we can say that d dx of x squared over x plus 3 is equal to, I'm just going to draw the fraction bar to help us out. So I need to start with my v function because that's what my formula tells me. So my v function is here. So is equal to x plus 3. And then I need to multiply it by the derivative of u, right? That du dx is the derivative of u, which in this case is 2x. Okay, I'm going to subtract it from my u function, which in this case is u squared. Sorry, in this case is x squared minus x squared. And then, again, I'm going to multiply with the times the derivative of v, so times 1. And I'm going to put it all over v squared. Okay, so you should be able to simplify this, and when you do, as we go through this problem, we're going to just start by distributing the 2x. So you're going to get 2x squared plus 6x minus x squared all over x squared plus 6x plus 9. And I simplified even further, I'm going to get x squared plus 6x over x squared plus 6x plus 9. Okay, now, one of you, I guarantee you, is going to say, ooh, I have an x squared plus 6 here. Ooh, I have an x squared plus 6 here. I'm going to cancel those out, but you can't, because on the denominator, this x squared plus 6x is part of this whole term. You cannot cancel out part of a term. So this is your final answer. This is your final answer. Okay, that's it for the day. Let me know if you have any questions.